today we're going to talk about two types of factoring. One is by grouping that we kind of already looked at when we did the AC method. And we're going to do another one. It's a special case called the difference of two squares. Okay, so these are the two for today. But by grouping and the difference of two squares. So we're still talking about factoring. Okay. Factoring is a huge part of algebra at this level. Being able to factor quadratics. That's kind of what we're digging into right now. All right. So let's start by knowing kind of when to use, basically when to use, what am I trying to say? Factoring by grouping. All right. So when we start out with, let's say, 5k to the third minus 25k squared plus 7k minus 35. Now, this isn't a quadratic. This is a cubic. Okay, it's a four-term cubic polynomial. If you remember from when we were naming our polynomials, this is 1, 2, 3, and 4. Four terms. And then if we look at the degree, okay, here's my highest exponent on the variable, and that is 3. So it's third degree four-term polynomial. All right, third degree is also known as a cubic polynomial. All right, so grouping, basically, there's a certain way we can look at it. If we go ahead and group the first two and the last two terms together, can I then remove things or factor out common factors so that I'm left with equal things inside the parentheses? Okay. So let me just show you what I'm talking about. Here, if we look at just this grouping here with the parentheses, I have a 5 and a negative 25 for my coefficients. So I can take out a 5. And then for my variables, I have a k to the cubed, and I have a k squared. So I could take out two k's, or k squared. Then what I'm left with here, if I take out the 5 and k squared, I'm just left with a k. And then here, if I take out a 5, I'm left with a negative 5. And if I take out a k squared, then I have no k. So that ends that. So 5k squared times k minus 5. And we can make sure that that is correct. If we multiply this back in, 5k squared times k is 5k cubed. Then we can also take the 5k squared and we can multiply that by the negative 5. And that becomes negative 25k squared. Okay. All right. Now plus. Now I've grouped these other two here as well. And is there anything I could take out of the 7k minus 35? Well, there is. I can take out a 7. So if I remove the 7, here I'm left with a k. And if I remove a 7 out of the negative 35, I'm left with a negative 5. Now, the reason this is significant then, as we saw with the AC method, we now have okay, and I'm going to rewrite that here because I know it was kind of confusing when we went over it with the AC method. I'm going to write this here with nothing inside, try to make it visually a little bit easier. They're going to represent being the same thing because inside it's just k minus 5 in both cases. So this is 5k squared times this box plus 7 times this box. So if I look at this, and what I wanted to do is kind of show it to you this way. So this is using shapes, obviously. But even if we used a variable, let's say that this was the variable z, okay? If I had, and I'll do it off to the side here, if I had 5k squared times z plus 7z, you could see that the z's are common factors to both terms, and I could pull the z's out. And I would have z times the quantity 5k squared plus 7. Okay? That is no different from what we're doing here. But instead of a z, I have a box. And really, instead of a box, I have these parentheses with the k minus 5 inside. But in this case, if I take the box and I pull it outside, just like I did here, the z comes out, right? The box comes out. Then I'm left with, just like I am here, 5k squared plus 7. Okay, 5k squared plus 7. If I pull that box out, which is what I'm doing, pulling the box out of both terms, there's my box. So now if I take the box and I multiply it in, box times 5k squared, there's what that is. And then box times the 7, that's what that is. All right, so instead of a box, I'm going to write what's actually inside, the k minus 5. So here, just rewriting it without the box. Now I have two binomials here and here. This one is linear, and this one is a quadratic, two-term quadratic, binomial, quadratic binomial. All right, now can I simplify that? I can't, because 5k squared plus 7, I'm not going to be able to break that down any further. All right, and that is factoring by grouping. And it only works on certain ones. You kind of have to take a stab at it to see if it's going to work or not. All right, let's do another one. Let's do 24x cubed plus 30x squared minus 4x minus 5. All right. Now, I didn't do this on my last one for a particular reason. I'm going to do it on this one. But notice here, I didn't change my minuses to plus negatives. And that's because really the crucial one is this middle plus here. That's the one that's going to give you problems if you don't change those to plus minuses. So I'm gonna show you what you have to do if we leave that a minus. All right, so if we leave that a minus, and I just put my parentheses here, just doing that would be incorrect. Because I would have to realize that if I distributed this -4 here, that would give me minus 4x. But then if I distributed that negative here, that would give me a plus 5. In my original equation, or I'm sorry, my original expression, this has to be negative. So if I'm going to leave that negative there, I have to change this to a positive when I put the parentheses around there. Okay. So let me rewrite this out. So kind of go over that a little bit because that can be kind of confusing. Oops, minus 5. All right, so this is the original one. Notice there's a minus here, there's a minus here. So if I do add parentheses here, and here, this has to change to a plus. The other way to do it is to go ahead and make all my negatives positives. So if I do 24x cubed plus 30x squared minus 4x minus 5 is to go ahead and turn those into positives. And the way that you do that is to say plus negative 4x plus negative 5. Now, when I put my parentheses around the final two and I separate by this plus, I haven't lost anything. Because if I multiply this plus 1 through, 1 times negative 4 is negative 4, and 1 times negative 5 is negative 5. So it still preserves this negative negative. If I add the parentheses here and leave the minus sign here, then this has to change to a positive because the negative times 4 gives me negative 4, but the negative times a negative would give me a positive, and I want this to be negative. So that's why this has to be plus, so that the negative times the positive gives me a negative. Or you can just switch them both to negatives. And that's probably the better thing to do right now. All right. Now I look to see what are my common factors in each group. So if I start here, I have an x cubed and x squared. Clearly, I can pull out an x squared. I'll pull out an x squared. And I can pull out of the 30 and 24. I can pull 3. Can I do anything bigger than 3? What about 6? 6, 12, 18. Yeah, I can pull out a 6. So 6 times 4x will give me 24x cubed. And then 6 times 5 will give me 30x squared. 6x squared times 5 is 30x squared. All right, then a plus here. Negative 4x plus negative 5, I could pull out the negative. And this can be 4x plus 5. And then up here, if I left that as a negative, notice this negative 1 here is going to turn that plus 1 into a minus. But here, I would have still had 4x plus 5. So either way that I do it, I'm going to end up with the same thing. All right, then we can see that we have identical factors here. So let me rewrite what we've got here at the top of the next page. Kind of out of room. All right, so that is 6x squared times 4x plus 5 plus negative, the negative 1 out there, or you can just write negative either way, 4x plus 5. All right, so now if I pull the common factor out, which is 4x plus 5, then what's left is 6x squared, and then plus this negative, which is a negative 1. Right? Now, plus a negative is just minus. So we can simplify this as 4x plus 5 times 6x squared minus 1. Right. Good deal. Let's do another practice one. Again, we're doing factoring by grouping. So this time we're going to do 40x cubed minus 5x squared minus 64x plus 8. All right. So here I'm going to change this minus and this minus. I'm going to go ahead and make them plus negatives. So 40x cubed plus a negative 5x squared plus a negative 64x plus 8. And again, I mentioned this earlier, but we're dealing here with a 1, 2, 3, 4 term degree 3 polynomial. Degree 3 is also called a cubic. So a 4-term cubic polynomial. All right, now I'm going to draw my parentheses. This is called grouping, where we group the first two and the last two terms together. And if we do that and we pull certain things out and they match what's inside these parentheses, then we can pull out the entirety of the parenthesis. And that's called factoring by grouping. So here I've got, go ahead and write this. All right, out of the x cubed and x squared, I can pull an x squared. Out of the 40 and the negative 5, I can pull a 5. If I pull a 5 out of the 40, I'm left with an 8. An x squared out of the x cubed, I'm left with an x. All right, and then plus negative. If I pull a 5x squared, I'm just left with a negative 1. Remember, that's not a 0 because 5x squared times 0 would be 0, and I need 5x squared times whatever's right here to give me negative 5x squared. That has to be a negative 1. All right, then here I have negative 64, and I have plus 8. So if I pull out a positive 8, I would have negative 8x plus 8. Now I want you to notice something. These are not identical. I'm sorry, if I pull an 8 out, that would give me a 1. Excuse me. All right, so this is negative 8x plus 1, and this is 8x plus negative 1. So what I can do is I can pull this negative out. If I have a positive here and I pull the negative out, that makes this a negative. So what I have is 5x squared times 8x minus or plus negative 1. And then here I'm going to do plus. If I pull the negative out, I'm going to have negative 8. Then here I will have 8x. And if I pull a negative out of the positive, I'll have a negative. Negative 8 times 8x minus 1, which is what I have here, 8x plus negative 1. Plus negative 1 is the same thing as minus. So 8x minus 1 plus negative 8, and this is 8x minus 1. All right, so now I can take that 8x minus 1, that common factor, and pull it out. 8x minus 1, and I'm left with here 5x squared plus negative 8. The plus the negative is the same thing as minus. So I'll just rewrite this in simplest terms. 5x squared minus 8. And that's your final answer. 8x minus 1, or the quantity 8x minus 1 times the quantity 5x squared minus 8. All right, good job. Next, what I want to do is what's called the difference of two squares, okay? The difference of two squares. Now we're going to use an interesting concept. All right. So if I have A plus B and I multiply that times A minus B. Okay, let's see what happens. So I'm going to take this quantity right here and I'm going to multiply it into this A, and then I'm going to multiply it into that negative B. Okay, so I've got A plus B times the quantity A, then minus A plus B times the quantity B. All right, now I can distribute this A through that over that plus inside those parentheses. So A times A is A squared. A times B is A B. All right, then we have minus. Then we have B times A. And I'm going to go ahead and drop since I have a minus here, I'm going to keep my parentheses because that minus, when I distribute it through, is going to make that negative and it's going to make that negative. So let's do one thing at a time. B times A is AB. And then B times B, B squared. All right, now let's take this negative and distribute it through. So this is A squared plus AB. Negative 1 times AB is negative AB. Negative 1 times positive B squared is negative B squared. Now we'll notice here that we have plus AB minus AB. So those are going to cancel each other out. And we're left with A squared minus B squared. And that's where we get this thing called the difference of two squares. If I have the difference of two squares, I can factor it back to A plus B times A minus B. Because when I multiply that out, I get to A squared minus B squared. So that will then factor into A plus B times A minus B. So in algebra books, you'll see A squared minus B squared is equal to A plus the quantity A plus B times the quantity A minus B. So if I have the difference of two squares when I'm looking at a problem, let's say x squared minus 3 squared. Okay. I'm going to put this in this form. If I have a squared minus b squared, I'm going to do a plus b. So that's going to be x plus 3. And then I'm going to do x minus 3. And that's your answer. Okay, if I have x squared minus 25. Well, 25 is 5 squared, so I have the difference of two squares. So this would be x plus 5, x minus 5. X squared, we'll do this one again, except I won't write 3 squared. I'll write 9. Same thing. 3 squared and 9 are the same thing. So this is x plus 3, x minus 3. Okay. And let's go ahead and do some examples. Up. Right. Let's go ahead and do 9x squared minus 4. Is this the difference of two squares? Well, it is, because right here, this is 3x squared. So that 9x squared is a square minus, and then this is 2 squared. So as long as I can show that I have two things squared with a minus between them, I can use the difference of two squares. So this is going to be 3x minus 2 times 3x plus 2. And if it helps you to go ahead and write, usually I go right from there to here. But if it helps you to write what the squares are, so 3x and 2, so that you can visualize it a little bit better, feel free to do that. The square root of 9x squared is 3x, and the square root of 4 is 2. So 3x squared, 9x squared, that's the same thing. 2 squared and 4 are the same thing. Same answer. All right. 25r squared minus 4. That's going to be 5r minus 2 times 5r plus 2. And how did I get that? 25r squared, what's the square root of that? Is 5r. So if I square that, I get 25r squared minus the square root of 4 is 2. 2 squared there. All right, I'll show you one that a lot of students get wrong. They'll see x squared minus 1, and they'll be stumped by that. They don't see that as the difference of two squares, but in fact it is, because the square root of 1 is 1. 1 squared is 1. So 1 is a square. So this is x minus 1 times x plus 1. Okay. Well, that one's pretty straightforward. So what I'd like to do now is we're doing a lot with factoring right now. So I'm covering both factoring by grouping and factoring the difference of two squares. But we also looked at the AC method last time and factoring the common factor and then factoring with quadratics with the leading coefficient equal to 1. So let's do a little bit of review, and then I'm going to work one example from each topic. So first, let's look at 25x minus 5. And let's go ahead and factor out the common factor here. This is not the difference of two squares. We can't do any grouping here. And this isn't a trinomial quadratic. There's no degree 2. It's not a quadratic. But what I can factor out is a 5. And I'm left with 5x minus 1. That's just factoring out the common factor. And you could have several. You can have, let's say, 30x to the 4th minus 25x to the 3rd plus 50x squared minus 5x plus 10, right? And then here, I could factor out of each one of these. This is a 5-term polynomial of degree 4. I could factor a 5 out of each one of these. And I'm left with 6x to the 4th minus 5x to the 3rd plus 10x squared minus x plus 2. Common factor. Everything has an x as well except for this, so I couldn't pull out any x's. All right. So after we learned common factoring, we looked at basic quadratic. Okay. Let me pull up my examples here. Give me just a second. All right, let's do x squared plus 2x minus 35. All right, so in this particular case, this is a quadratic. This is a degree 2, and we have a trinomial. So I want to cover a couple of things here. One, a quadratic always takes the form of ax squared plus bx plus c. Okay, there's always that form. So if I look at a, b, and c are the coefficients. So over here, whatever number is in front of the variable is the coefficient. Okay, you say, well, there's no variable here. Well, there actually is. It's x to the 0. X to the 0 is 1. 1 times negative 35 is just negative 35. We're not writing the x to the 0. But here we have a, b, and c. So what are my coefficients? A, there is no number there. There actually is. That's a number 1. 1 times x squared is x squared. If that was 0, 0 times x squared, there would be nothing. You would have 2x minus 35. But you don't. You have an x squared. That's because there's a 1 in front of it. All right, then my b is 2, and my c is negative 35. Okay, those are my coefficients. Right? Remember, this is what's called a quadratic or a degree 2. And this is a trinomial or what's called a 3-term polynomial. Same thing. Okay. So we have a 3-term polynomial. It's degree 2, which means it's quadratic. All right. This is the normal form that every quadratic takes. And we have coefficient 1, 2, and negative 35. So how do I factor this? To factor this trinomial can factor into 2 binomials multiplied together. And as long as your leading coefficient, the number in front of the leading term, which is the high degree value, which is 2, okay? As long as that number is 1, we can look at this as x plus something, x plus something, okay? Now, we need 2 numbers that when I multiply them together, they'll give me the final term here, which is negative 35. Those same 2 numbers, when I add them together, have to give me the middle term of positive 2. So what 2 numbers add to give me 2, multiply to give me negative 35? Well, it can't be 1 and 1, right? That adds to 2, does not multiply to give you negative 35. Now, 35, I can get to by multiplying 7 and 5. But I also need to add together to get positive 2 and multiply to get negative 35. So I know that if I have a positive 7 and a negative 5, that if I add those 2 together, I get a positive 2. If I multiply the positive 7 and the negative 5, I'll get a negative 35. So then my 2 numbers are positive 7 and negative 35. So positive 7 and negative 35. I'm sorry, negative 5. And plus negative 5, I can just rewrite that. X plus negative 5 is x minus 5. So that is the answer. That is that factored. All right. Good. All right. So what do we do when that leading coefficient is not 1? Right? Let's say you have 7x squared minus 46x minus 80. All right, so this is a quadratic. If I look at my coefficients, my A is positive 7, my B is negative 46, and my C is negative 80. Now, how can I factor this? Can I do the same thing? Two things that multiply to give me negative 80 that add to give me negative 46. No, I cannot because A does not equal 1. Can only do that if A is equal to 1. In this case, A is equal to 7. So I'm going to use the AC method. Okay. AC method starts with A times C. So that's 7 times negative 80. Let me do that over here. 80 times 7. The positive times a negative will just give me a negative. So 0 and 56. So 560. All right. AC is negative 560. So I want two numbers, okay, that multiply together to give me negative 560. But when they are added, they give me the middle term of negative 46. All right, I certainly don't know that off the top of my head, so I'm going to do some factoring, the factor tree. So I'm going to look at 560. I know that's 10 and 56. All right, 56 I know is 8 and 7. 10 is 2 and 5. 8 is 2 and 4. And 4, of course, is 2 and 2. All right, so I have 2 times 5 times 2 times 2 times 2 times 7. All right, so let's look at kind of numbers we can get here. Okay, so we've got 10 times, well, obviously that would be 56. We've got 8 times 10 times 7, which is 70. Here we've got 14 times 2 is 28. And then over here we have 2 times 2 is 4 times 5 is 20. Well, that's 48. If I add those two together, I'm getting close. Let's see. 5 times 7 is 35. And then 2 times 2 times 2 is 8, times 2 is 16. Does that get me to 46? No. So 10 times, oh, I already did that. 10 times 2. 10 times 2 is 20. Times 2 is 40. And then 2 times 7 is 14. It's not that either. Wait, what about, oh, here we go. Good Lord, it's the first one, 56 and 10, because 56 minus 10 is 46. You guys watching online probably already knew that. All right. So, in order to, if I multiply 10 and 56, I get 560. One of them needs to be negative, because this is going to be negative. and I need a negative 46. So that means I'm going to need a negative 56, and I'm going to add a positive 10. So negative 56, positive 10. Those are my two numbers right there. All right. So now what I'm going to do is now that I found those two numbers, for the AC method, we're going to rewrite 46 as a combination of those two. So this is going to be, and I'll go ahead and write it here, 7x squared minus 56x plus 10x minus 80. All right. So I'm going to carry that on to the next paper so that you guys have just rewriting what I just said, 7x squared minus 56x plus 10x minus 80. Okay, so here I am going to do my grouping. I've got a plus sign right here, so I don't necessarily need to turn any of these to plus a negative, but it might be a good idea to just do it all the time until you kind of get used to how these work. So plus negative 80. All right. So now let's see if anything will come out. So I can pull a 7x out of both of these. So if I pull a 7x, this is left with x here. And then plus, if I pull a 7 out of 56, that's a negative 8. And if I pull an x out of x, that just leaves at x plus negative 8. Here's this plus sign. And then 10x plus negative 80, I could pull a 10 out. And this gives me x plus negative 8. All right, so x plus negative 8, x plus negative 8. I can pull that out. So that's x plus negative 8. And I'm left with 7x plus 10. All right, and that plus minus is just a minus. So that's x minus 8 times the quantity, 7x plus 10. All right. And that is the AC method. Now, let's do one by grouping. Let's do 18x cubed plus 21x squared plus 12x plus 14. All right, so grouping, I'm going to group the first two together. Then I'm going to start pulling common stuff out. So 18 and 21, I know I can pull not a 7, a 9, no? 3? Oh, yeah, 3. So I can pull a 3 out, and then x cubed and x squared, I could pull an x squared out. So if I pull a 3 out of the 18, that leaves me with 6, a 2x squared out of the x cubed, that leaves me with x. Plus, if I pull a 3 out of the 21, that leaves me with 7. Pull an x squared out of the x squared, and I just have 7. Plus 12x plus 14. If I could pull a 2 out of the 12 and 14. 2 out of the 12 is 6. X out of the 14, 7. All right, so we have two identical things in parentheses, the quantity 6x plus 7. So I'll pull that out. Here is 6x plus 7, and then I'm left with 3x squared plus 2. Very good. Now let's look at the difference of two squares, and we'll be done. So here I'm going to have 4y squared minus 1. Okay, so the square root of this is 2y, and the square root of this is 1. So this can be 2y minus 1 times the quantity 2y plus 1. There you go. All right. That brings us to the end of the class period today.